We've all seen the headlines about China building entire cities in record time, the so-called ghost cities. But the latest rush isn't into housing, it's into AI data centers. Between 2023 and 2024, something like 500 of these projects were announced. On the surface, it looks like a massive tech boom, but when you peel back the layers, it starts to feel a lot like the old real estate playbook.
It's a perfect comparison, Frank. In many ways, it's a literal replacement. You had all these local governments that were completely dependent on land sales and the property market for revenue. When that market collapsed, they desperately needed a new growth engine. So, AI and computing power became the new luxury condos. But here's the unbelievable part. Recent reports suggest that up to 80% of that newly built computing capacity is just sitting idle. It's the ghost city phenomenon all over again, but this time with empty server racks instead of empty apartments.
That 80% figure is just staggering. I mean, it's hard to get my head around. If these billion-dollar centers aren't actually being used, why on earth did they keep building them? Was this just a classic case of build it and they will come, or was something more cynical going on with all the government subsidies?
Well, it was a perfect storm of both, but mostly the latter. It became what's been called a political promotion checklist. For a local official, having AI, computing power, new energy vehicles on your resume was a fast track to advancement. It wasn't about meeting actual market demand, it was about political optics. So you had real estate developers, fresh from the property bust, suddenly rebranding themselves as digital infrastructure experts and building these massive facilities with no real understanding of how to operate them.
So they were just building the shells.
Exactly. And for some, it was even more cynical. The reports suggest a kind of subsidy arbitrage. Operators would get the permits to build an AI data center, which gave them access to all sorts of government goodies, cheap land, tax breaks, and most importantly, cheap industrial grade electricity. Some of them apparently had no intention of ever running a single AI model. They just wanted to capture the subsidies or, in some cases, resell the cheap electricity back to the grid for a profit. It got so bad that Xi Jinping himself had to issue a warning against these reckless decisions and hasty investments.
So we have a massive oversupply of physical buildings run by people who don't know what they're doing, and some who are just gaming the system. But I guess having the building is the easy part. The real mess started when they tried to actually connect all these servers to the internet.
Right. And that's where the Grand National Strategy completely fell apart.
This was the plan called East Data West Computing, right? The idea was to move all the heavy, power hungry AI training to the western provinces where electricity from renewables is cheap and plentiful. On paper, it sounds brilliant. In reality, it seems to have been a logistical nightmare.
It's a classic story of a great idea on a whiteboard that fails in the real world. It's a fundamental mismatch. AI training, the initial process of teaching a model, can happen over weeks or months. It doesn't matter if it's in a remote location, but AI times usage times what we call inference, the part where you actually ask the model a question and get a quick answer that needs to be physically close to the user. Western provinces like Guizhou have the cheap power, but they are thousands of miles from the big population centers and lack the ultra-high-speed fiber optic pipes to get the data back to Beijing or Shanghai without a noticeable delay.
I see. So it's like having a gigantic water reservoir in the desert, but only having a tiny, leaky straw to drink from it 1,000 miles away.
That's a perfect analogy, and the numbers bear it out. Those Western data centers are running at a dismal 30% utilization, nowhere near the national target of 60%. Meanwhile, all the hot data, the real-time valuable stuff, is still being processed in expensive data centers in the East, close to the users.
If I'm an AI startup in Shenzhen, why would I ever choose a server in a remote province that adds a split-second delay to my app? Even if the electricity is half the price, that latency would kill my product.
You wouldn't. and they didn't. The cautionary tale here is Guizhou. It was the poster child for this whole big data push. The government poured in massive subsidies, but the economic miracle never happened. The province's GDP ranking has actually fallen, and now there are reports of corruption probes into the whole big data sector. It shows that in the AI world, you can't outrun the physics of latency with a government mandate.
So you've got a geographical mismatch and a massive surplus of idle servers. The situation is already a disaster. But then in early 2025, a single company called DeepSeek comes along and releases a model that basically changes the rules of the game for everyone.
Yes, just as these massive, expensive data centers were finally opening their doors, DeepSeek dropped a bomb on the entire industry. Their new AI models were so efficient, they showed you don't need a mountain of chips to get top tier results. A smarter algorithm could do the work of a much larger, dumber one.
It's the ultimate irony. They built all this infrastructure for a brute force approach, and then the technology just evolved past it overnight.
Exactly. The very premise these data centers were built on, that more compute power is always better, was suddenly outdated. DeepSeek essentially deflated the entire market for massive, generic compute clusters. It's why GPU rental prices in China have plummeted. All that hardware is like a giant gas guzzling V8 engine in a world that just invented a tiny, hyper efficient electric motor.
It sounds like they built a massive fleet of heavy cargo ships right when the world switched to 3D printing everything locally. How do you even begin to repurpose that kind of specialized, expensive investment?
You can't, not easily. Many of these centers were physically designed for high density training, these incredibly heavy, power hungry racks of GPUs packed together. But the new demand is for low latency, agile setups for inference, which require a totally different layout. Engineers are now scrambling to refit buildings that were finished only months ago, trying to make them compatible with a software landscape they just didn't see coming.
This could have been the end of the story, a colossal, embarrassing waste of capital. But instead of backing away, it seems Beijing is actually doubling down with a nearly $300 billion plan.
That's right. If this were a private market, you'd see a spectacular crash, bankruptcies, the works. But in China, the response is to go even bigger. They've announced this huge 5-year, $295 billion plan to build a unified national grid by 2028.
So, what does that even mean? A unified grid?
It's a hard reset. Beijing is basically stepping in and saying, all right, local governments, you all made a mess of this. Now the state is taking over. The plan is to have state owned giants like China Mobile and China Telecom consolidate and run everything. They're imposing strict new rules, like banning new centers in cities where utilization is below 50% and forcing everyone to hit a 60% minimum. And here's the most important part: they're mandating that this new grid must run on 80% domestic chips.
Ah, so this is about Huawei.
This is all about Huawei and other domestic players. They aren't trying to save the old failed projects. They're trying to absorb them, nationalize them, and rebuild them into a single state controlled homegrown AI machine.
Okay, but if they move to 80% domestic chips, what does that mean for the actual performance of Chinese AI? Can Huawei's hardware really keep up with what Nvidia and others are doing at the global frontier? Or is China essentially deciding to build its own walled garden that's secure, but maybe a generation or two slower?
That is the multi-billion-dollar question. From Beijing's perspective, they seem perfectly willing to write off the wasted early investment as a learning cost. The short term goal isn't economic efficiency, it's long term strategic dominance and technological sovereignty. They don't seem to mind if their walled garden is a bit slower, as long as they control the walls.
So if we just step back for a moment and look at this whole saga, what are the big lessons here? It feels like more than just a story about bad investments.
I think the biggest lesson is that in the world of AI, capacity does not equal capability. China built a monumental amount of raw capacity, but because it was driven by political incentives and real estate speculation, not actual technical demand, much of it was useless. It was infrastructure as political theater.
And it highlights this incredible mismatch in speed. The technology, like DeepSeek's breakthrough, moves on a weekly or monthly cycle. But physical infrastructure building a billion-dollar data center moves on a multi-year cycle. The hardware can become obsolete before the ribbon-cutting ceremony even happens.
Precisely. And that leads to the final piece, which is Beijing's reaction. They don't see the current mess as a failure of the system, they see it as a necessary, messy, chaotic first draft. It's a phase they had to go through before the state could step in, exert total control, and consolidate everything into a unified, domestic chip powered national grid. They're not mourning the wasted billions. They're viewing it as the price of admission for building a state controlled digital monopoly.
We often talk about the AI race as if it's a competition of raw numbers, who has the most chips, the most electricity, the most data centers. But China's current predicament suggests that in the AI era, abundance can be a trap. Having the most bricks and bytes doesn't matter if they are in the wrong place, running the wrong chips, or using an outdated logic. The real risk for China, and perhaps for US hyperscalers too, isn't a lack of investment. It's building a monumental past right when the future decides to change the rules. We are moving from an era of brute force to an era of surgical efficiency. And in that transition, a massive idle data center might just be the most expensive paperweight in history.